In this video, I'm going to show you how to create a depth first search using pre-order in a binary search tree. So let's go ahead and set up this function. So I'm going to do DFS, short for depth first search, and then pre-order. And just to let you know, depth first search has three possible ways in which we can perform a depth first search. You got pre-order, in order, and post order. So for this one, we're doing a pre-order. All right, to set up our function, we're going to set the result variable equal to an empty array. So we're going to do let result equal an empty array, and this result will be returned to us at the end of the function with the final output. Next, set up inner function called traverse. All right, so this particular function that we're doing here is going to be called recursively. So that means that traverse, that we're going to be calling it multiple times, but each time we call it, it's going to have a different input. All right, that's what's going to make it recursive. And so this is what we're going to do. So set up the inner function called traverse. Okay, so we're going to do function traverse, and we're going to start, and we're going to give it a starting input of the current node, and the current node, as you can guess, is going to be the root node. So next, inside this function, we're going to push current node's value into the result. So we're going to get the result dot push and push the current node dot value. So we're not pushing the entire node object, we're just pushing in the value. Next, if current node has a left child, then call traverse function with the left child. So as I said, traverse, we're calling it the function again within itself, but this time it's going to have a different input. All right, and that input is going to be the left child. So if current node dot left, if that exists, then we're going to call traverse again. So traverse, and we're calling it within its own function again, but this will be passed a different argument, and that is current node dot left. And the same thing as we did just now, but this time with the right child. So if current node has a right child, call traverse function with the right child. So if current node dot right, traverse current node dot right, and this is it. And one of the reasons why we're able to make this whole entire function short is because we're using recursion. That's one of the things with recursion instead of iteration, is that it makes the code a lot shorter. However, in my opinion, it gets very complicated when to try to wrap your mind around recursion. So definitely, if you don't understand recursion, review that, because it's difficult to grasp, but over time it'll make sense. All right, but we are using recursion here, and it's often used in graphs and trees when you're traversing in other programming situations that you have. So here, now that we have our depth first search pre-order complete, let's go ahead and, and by the way, of course, we have the function declared here, but it's not going to run unless we execute it. And as a matter of fact, I have to continue the pseudocode here, right? So once we complete that, at the end of the function, we're going to execute traverse function with starting input of root node. Okay, so here we have to execute traverse, and the starting input, we're going to pass in this dot root. All right, so that's going to be our starting point. We're going to start at the very top of the root, at the tree. All right, at the root. So that executes the function, and then finally, of course, we need our result. So return that, and that is it. So let's go ahead and test this out. All right, so we got our tree here with all the insertions that builds out this tree here. So let's go ahead and do a console log of tree.depthFirstSearch pre-order. And if we do that here, I'm going to expand my console and then execute, run this code, and look at what we get here. We get 10, 7, 3, 9, 12. And pre-order, we're going to start at the very top and insert that value immediately into the result, which is 10, and then work our way to the left, which is 7, and then continue all the way to the deepest possible route, going to the left, and then we get to 3, and then at that point, recursion, because we're using recursion, and it's going to realize, okay, we don't have any more further to go. We're going to start popping off traverse functions from the stack, which means it's going to start backtracking. So at that point, it's going to backtrack back here, and it's going to say, okay, well, we left off over here, so do we have anything to the right? And we do. So then it's going to push to 9, and then finally it's going to, the same thing, it's going to realize there's nothing to the left and the right as a child, so it's going to backtrack again to the 7, and then backtrack to 10, and then move its way to the right, which is 12. So again, it's going to do 10, 7, 3, and then 9, and then 10, and then 12, and that's what we get over here. And that is your depth first search pre-order.